Welcome to the Stormsurf video surf forecast for the week starting Monday, May 29th. Looking at significant wave heights for the South Pacific Ocean, we see remnants of a gale out of the California swell window, falling southeast and of no interest to us, but another gale is trying to develop in the central South Pacific and has some potential for the future. Otherwise, nothing of interest is occurring. Let's get into the details. As usual, we're starting our tour looking at jet stream level winds. These winds of about 30,000 feet help support the formation of gales when they do form, help direct their track. We're looking for a trough that is a dip in the jet stream pushing to the north. And we see a bit of one right here. Winds are rather weak, peaking out at 100 knots. And normally, one would not expect that to be particularly supportive of gale development. So let's talk about this a minute. We have winds pushing to the northeast. That would make a clockwise flow in the southern hemisphere, and that is the hallmark of low pressure. And that also rotates down at the surface clockwise way. That generates wind. Winds generate seas. Seas generate swell when they radiate away from the fetch area and arrive at your beach. So right this area here, let's just sort of see how it goes. And it does not at all look impressive into Tuesday. And then it sort of starts moving out of the California swell window. Notice wind's just very weak. So one typically would not expect a whole lot to occur. Now notice this trough redevelops some on Wednesday night into Thursday, and you have a little bit of 120 knot winds there feeding it. But again, out of the California swell window. Otherwise, we have a split jet stream flow. The northern branch running down around 22, 23 south. The southern branch generally down around 60 south, but then also almost another little trough. Looks like it's trying to organize Friday here southeast of New Zealand. Let's see if it does. And yes, very weakly. Again, the wind's just 60 knots. That's not really doing a whole lot to say. Normally, you'd want to see winds up in the 130, 140 knot range pushing to the northeast. Bit of a ridge building here, also a ridge building under New Zealand. That typically would support high pressure in between the two streams of the jet there. And of course, that is not supportive of gale development. But then we get out about 156 hours into Monday, so we're talking a week out. The trough gets a bit more organized, kind of pinched a little bit, but not horribly so. Maybe something could come from that. And then that's almost another trough trying to develop here come Tuesday under New Zealand. So there are some areas of interest, but nothing that just jumps out and screams gale development. Next, let's take a look at surface level pressure, surface level winds. And unexpectedly, we see this area, remember there's a trough here, but very weak winds in the upper level. Still 35 knot winds. That's probably not enough to generate swell. You really want to see at least 40 knot, preferably 45 knot or above. But anyway, as that continues into Tuesday, 35 knots, but aim pretty well to the northeast. Maybe something will come of that. And then a secondary little fetch developing come Tuesday night. 45 knot winds over a tiny little area, but pretty much falling southeast and out of the swell window. Nothing going on there. Then we continue to look for something here between, so Southern California is at 117 west. And then the swell window relative to Hawaii and California is right along here in New Zealand. Just looking for any preferably 40 knot winds. See something trying to organize here 150 hours out, but no, doesn't. Remember, there was a trough right here, very weak winds, and the expectation was that there would not be a whole lot of fetch that would be generated from that. Oops. And then we're out 180 hours. There was another trough over here, but nothing indicated on the charts yet. But sometimes, especially this model, the GFS model, the upper level winds, the 250 millibar winds, will suggest something, and it takes a couple of runs for it to start showing up down at the surface. So we're not going to give up on it just yet, but just a quick glance, nothing super obvious other than the one gale that's supposed to develop in the next 24 to 48 hours. Let's go take a look at the wave model charts. So here we go, significant wave heights. This guy we've pretty much written off. He's out of the swell window. It's this one right here that we're going to keep our eyes on. A little bit of fetch. And now remember, winds only got to maybe 35 knots or so with this one. But by Tuesday, we're supposed to have 28-foot seas. This says 30, so we'll say 29-foot seas. There's your 30-foot seas on Tuesday, 12Z. So that's tomorrow. And in the California swell window, and aimed a little bit to the northeast, and lasting just 12, 18 hours or so, and then falling out of the swell window. So probably good for a little Little pulse of 16-second period swell favoring Southern California on down into Mexico, but some energy pushing up into Northern California as well. Now we have another system here. Not sure whether that's quite in the swell window yet on Wednesday, and notice it's also falling southeast into Antarctica, the Ross Ice Shelf. No hope from that. We'll just roll this off. We're looking for anything 28-foot seas or greater, so a 28-foot sea will get you about a 16-second period swell, and that has good, from there on up, has doesn't decay too much and has a reasonable chance of making it to California. From over here in New Zealand, you're talking 6,400 nautical miles. That's depending on the period, anywhere from 8 to 10 day travel time, but still 16-second periods can hold reasonably well. Whoops. And that was it, 180 hours and basically nothing other than this little guy here that's falling southeast. So really just the gale that's forecast in the next 24 hours is what's on the charts. Now let's go back in time a little bit. And of course, if you haven't noticed, there is swell hitting California right now. Southwest swell from a gale previously off of New Zealand. We don't have that in the archive anymore. That swell hit Hawaii a couple of days ago and is already pretty much gone. It's pretty close to peaking in California right now, but we'll get a couple of days out at fun little waves anywhere from waist to chest high and better spots that do well on southwest swells or hitting head high or maybe a little bit more on the biggest sets. Anyway, so then we're talking Thursday of last week. Another gale developed here in the central South Pacific. Little patch of 28-foot seas about midday Thursday, up to 30 foot and maybe 31 feet later Thursday. And actually aimed pretty well to the northeast and certainly in the California swell window. Now Hawaii, Oahu's at 158 west, so right there. Kind of doubtful whether that energy is going to go due north, but maybe we'll call it a little pulse of background swell, possibly about a week out from Thursday, and a little bit beyond for California, probably next weekend. Some small swell, something to ride, but then after that, that was pretty much it. Now notice this strong system off here. This is as of earlier today with up to 50-foot seas, but it's falling southeast and out of the California swell window. Literally no swell is expected from that. Let's take a look longer term. What's going on, let's say, beyond a week out and maybe 3, 4, 5 months out. Again, accuracy, not the forte of models and any forecast that far into the future, but it gives you sort of a hint or some general, just a trend of what might be coming. So first off, the first pattern or cycle that we look at is the Madden-Julian oscillation. In the inactive phase, that tends to suppress swell development. In the active phase, tends to enhance swell development or storm development. In winter months, in the Gulf of Alaska and the Dateline region, so that we're focusing really on Hawaii and California there. But in the summer months, sometimes the active phase enhances storm production in the southern hemi as well. And specifically, there's one area we look at, we call it the Kelvin wave generation area, runs from about 135 east to about 170 west. So that's New Guinea there, far east Pacific here, far west Pacific here, and on the equator, just 5 degrees north and south of the equator, so you can draw a little box right there, okay? And when the active phase of the MJO moves over this area, trades tend to get suppressed. And when it does that, it allows moisture and energy to move into the jet stream, both north and south, and that, in turn, helps enhance storm production. Anyway, so actual trades, this is from the TAO buoy array, actual buoys on the ocean surface, but this is a 5-day average, so winds can actually change, and it'll take about 2 or 3 days before these charts will pick up on it. But still, it gives you, it's the best source we probably have, and not only that, it also, we can get anomaly data, differences from normal for this time of year. So, actual winds blowing pretty brisk over the East Pacific and across the whole way over the Dateline region, the equator over the Dateline. Trades, typical, out of the East this time of year, but it's the anomalies. Differences from normal for this time of year. A little bit of easterly anomalies going on over here off of South America, and the Kelvin wave generation area right in here, pretty much neutral, maybe weak east anomalies, indicative of perhaps the inactive phase of the MJO. Let's go look for more evidence. 850 millibar winds is up about 40,000 or 4,000 feet, sorry. And the Kelvin wave generation area right in here, again, 170 west to about 132, 5 degrees north and south. Yellows suggest westerly anomalies, blues easterly anomalies. May 23rd, kind of a neutral pattern. This is well south of 5 south, not part of the area we're looking at right in here. We just go, this is day by day by day. The trend generally looks by the 27th of May to be building easterly anomalies. So that is another piece of evidence suggesting the inactive phase of the MJO. Here's yet another way to look at that. 850 millibar winds, again, going back in time, April 29th, working our way to the future. The Kelvin wave generation area, that's 180 west, and that's, that's, what is that? Probably about 130 or 120, and that's 180. So the Kelvin wave generation area, roughly in between these 2 points. And we saw some westerly anomalies in early May, suggestive of the active phase of the MJO, then blues and purples, strong easterly anomalies, indicative of the inactive phase of the MJO. Here we are right now. Now, here's another interesting point. Notice, up at 4,000 feet, strong easterly anomalies indicated, but down at the surface, not so strong. So that's kind of good. Thank goodness the winds aren't as strong down at the surface. It'd be a horribly strong inactive phase of the MJO and would certainly just squash any storm development potential. And the better part about this is look out. So this is a 1 week window here, and by about 5 days out, by June 3rd, easterly anomalies are to die, and at least neutral, if not maybe a weak tendency for westerly anomalies. Per this, what is this, the GFS model? It doesn't say it, but the assumption is that it, oh yeah, GFS right there, of course. So, yes, probably at least a return to a neutral pattern. That's good news. Let's go look for more of outgoing long wave radiation forecast charts. Fancy way of saying cloud cover. More clouds suggests the active phase of the MJO, lower pressure. Okay, and blues are, see the negatives? That means less sunlight reflectivity off the ocean surface, means more clouds, means the active phase of the MJO. And of course, the yellows and oranges, more sunlight reflectivity, suggesting high pressure, suggesting the inactive phase of the MJO. Now, the nice thing about this, per the statistical model, it suggests that in about 5 days, the inactive phase is to die. So that correlates well with the GFS model we just saw. And then coming about 2 weeks out, perhaps a weak tendency for the active phase to start moving into the West Pacific. Now, the GEFS model, that same model we just looked a minute ago, shows, yes, easterly anomalies dying about 5 days out, but then coming back. So there's a bit of a disconnect between the two models. Pretty good correlation for the next week, but then you get 2 weeks out, and they're going in opposite directions. So who knows? Let's go dig some more. The ECMF model. Okay, these are phase diagram charts looking down on the North Pole. The active phase of the MJO moves from the Indian Ocean to the Maritime Continent, off to the east, over the West Pacific, under the United States, across the Atlantic, on the equator, on top of Africa, and then back to the Indian Ocean. The heavy dot is where the active phase of the MJO is. So, yes, this correlates well with all the other models, suggesting it's in the Indian Ocean. The further away from this circle you are, the stronger it is. So this is a modest active phase of the MJO, but forecast to build over the Maritime Continent was that 1, 2, 3, 4, 5, 6, about a week out, and then collapse as it moves into the Western Pacific. Okay, the GEFS model, Ensemble GFS model, suggests, yep, the active phase moving to the east, collapsing completely, and not moving into the Western Pacific, just sort of dissipating. So again, a little bit of difference in the outcome of these two models. And then the upper level model, so yellows and oranges are, so this is about precipitation. Less precipitation, greens more precipitation. This, of course, would be the inactive phase of the MJO. This model runs about 2 weeks ahead of what actually happens down at the surface. But it suggests the inactive phase of the MJO is to be moving, oh yeah, here we go, Central America, South America, New Guinea there. So you just sort of get your bearing here. This is Pacific Ocean, the equator running right along here. Inactive phase moving out of the Pacific come, oh, it says June 6th, so about the middle of June. Active phase finally moving in about that same time, and then it makes its trek across the Pacific through about the end of June, the 28th of June, and then the inactive phase moving in behind that. All these, call them modest in strength. None of them strong, but not weak. Just kind of a little bit weaker than normal pattern, we'd say. And then our favorite model, the CFS model, again, 850 millibar winds. So the yellows are westerly anomalies in this case. The blues are easterly anomalies. Kelvin wave generation area right in here. So, and this one goes, the forecast is in the future, past performance is here. Right now, this sort of looks like the inactive phase of the MJO, blue anomalies right here. But then come about June 6th or so, weak westerly anomalies start developing. And notice the trend here for the foreseeable future is westerly anomalies in the Kelvin wave generation area, suggesting at least the active phase of the MJO. So let's overlay the MJO. Here we go. Sure enough, the dotted contour is the inactive phase of the MJO. That correlates well. Then the active phase tries to come in, stalls a little bit, come around June 14th or so, but doesn't dissipate completely, then finally gets its act together come late June, and that's what's driving the westerly anomaly pattern here. That all looks good. Let's look at the low pass filter. So this gives you a sense of what's going on with La Nina or El Nino. So the dotted contour is La Nina over the Kelvin wave generation area. That sort of suggests that the way we look at this is it's suppressing the potential for Kelvin waves to be generated, which would therefore mean you got to have Kelvin waves to have El Nino. That is eastward propagating or west wind anomalies that allow for eastward propagation of warm water, okay, and have that warm water build up along South America. So supposedly La Nina is supposed to be dead come June 10th or so. And then we look further out here. Now, here, you can see this here. Here is where the potential for westerly anomalies is. It's all sitting in the Indian Ocean. This is pretty typical of the pattern during La Nina. Lack of potential in the Pacific, all the increased potential in the Indian Ocean. And then we get into July, and look at this. La Nina, it looks like, is trying to come back, perhaps a bit eastward, displaced more over California and less over the Kelvin wave generation area. That would be good for swell production. It might not bode so well, though, for rain production in California coming next winter, if one is to believe this model. Now, the other thing that goes on is this model's been teasing about this westerly wind thing going on for months now. It was supposed to start in May sometime, and now it's pushing out to June, and every day you move closer to it, the forecast pushes the development of these westerly anomalies off a day or two. So it's sort of like you're chasing a rabbit that you just can never get close to. But we'll see. We're getting closer. We'll see what really happens. All right, so much for the MJO. We know we're in the inactive phase now. Theoretically, we're going to move into some sort of weak active phase. We'll say 2 weeks out or so. Let's see what's going on in the ocean, and specifically we're looking at El Nino, La Nina thing right now. Surface water temperatures, West Pacific here, East Pacific here. This is the actual surface. These are the TAO buoys strung along the equator. The X's are the sensors that run down the buoy line, the anchor lines, and then those sensors give us an idea of what's going on at depth with ocean temperature. If we were in La Nina, all your warm water would be balled up here, and the depth of the warm water off of South America would be very shallow. What we've actually been seeing is the 28-degree isotherm line. It, for all of last year, was balled up here around 175, I believe. Then about 3-4 weeks ago, it started making this incursion off to the east, and now it's holding pretty good at 145 west, so that's a bit east. This is on the equator, a bit east of Hawaii on the equator. And then the 24-degree isotherm has actually gotten a little bit thicker. It's almost, let's say, 90 meters deep here at 140 west. It was up around 75 and even shallower than that, and continues on into Central America. Anomalies, differences from normal for this time of year. If we were in El Nino, you would want to see a pretty big ball of warm water here, and you'd want to see occasionally balls or pulses of warm water pushing off to the east, and then warm water building off here in the east. Now, we haven't seen really those pulses of warm water pushing off to the east would be what we call a Kelvin wave, and that would be generated by westerly anomalies or trades dying right over here in the Kelvin wave generation area. The natural forces just allow the warm water to start sloshing east. Now, we haven't seen much of that, but just the same, we see warm water 3 degrees above normal, almost 4 degrees above normal here in the far East Pacific. Sort of looks like El Nino. But you'd want to see a lot more warm water over here so that as we move into the fall, as westerly wind bursts, if they were to develop, there was something to move off to the east. But there's nothing here. I mean, it's almost dead neutral. So it seems like there's almost an early El Nino kind of thing, like a spring El Nino if there were such a thing. And in a way, that's kind of what happened. Peru got a lot of warm temperatures, a lot of rain, a lot of wind. And still seems to be holding at least the warm temperatures. Anyway, let's look at some other data. Here's another variation on that same model, and it basically says the same thing. Not a whole lot of warm water over here, maybe half a degree anomalies, maybe 1 degree anomalies on the date line, and a pulse of warm water working its way off to the east, and then here's that warm water along Central and South America. Upper ocean heat anomalies, so upper 300 meters of the ocean, and this is June of 2016. Cooler, the blues are cooler than normal. So this is suggesting La Nina, and cooler than normal water here in the Central Pacific, working its way off to the east. But then we got into about, we'll say, January of this year. All of a sudden that started breaking up. La Nina started breaking up. Look at this, a migration of maybe half a degree above normal water, moving from west to east. That sort of smells of a Kelvin wave, doesn't it? And then, boom, warm water. What is this? 1, 2, 3, a degree or a degree and a quarter above normal. Then it sort of dissipates a little bit. There's the upwelling phase of the Kelvin wave cycle. And now another Kelvin wave, it looks like, is moving off to the east. Now, the issue is, notice these 2 Kelvin waves, if they're so weak that you could hardly call them Kelvin waves, but notice there's no more warm water off here in the far West Pacific. So odds are you can't have any Kelvin waves. Even if you had westerly anomalies, there's no more warm water to move east. Wondering if this pocket of warm, again, springtime, notice the dates here, if this springtime El Nino sort of pattern will fade off as we get into the fall. Sea level anomalies, here's the equator, here's the date line, South America there, New Guinea there. So if you strip out all the waves, strip out wind-generated wind waves, strip out tides, and what you're doing is the satellite is mapping the height of the ocean surface, and we're talking down to centimeters, 5 centimeters, 10 centimeters, something like that. And where you see those above average heights by just a couple of centimeters, that suggests warm water at depth. Warm water, of course, expands and then creates a little bulge on the surface. Cool water contracts, makes a little depression in the surface. What we see here is a little pocket of warm water there, little pocket off of South America, suggesting maybe some weak kind of Kelvin wave traveling from, in fact, there was a tongue of warm water a couple of weeks ago that went from here the whole way out to here and back, certainly suggestive or indicative of a weak Kelvin wave, but it's making its way off towards South America, but kind of falling apart along the way. And again, this does not indicate any copious amount of warm water over in the West Pacific. How do you get warm water in the West Pacific? Well, typically you get a multi-year La Nina. Trades nuke all the warm water that builds up here, even in the summer, gets blown off to the west. The more the trades nuke, the more the warm water builds up here, creates this big old bubble. We'll say 10 or 15 centimeter anomalies would be expected over in here. Then all of a sudden, at some point, the atmosphere can't take it anymore. The trades die, and all this warm water just whoosh, and starts swashing back towards South America in the form of multiple Kelvin waves, and then you get El Nino. And the atmosphere, of course, changes as the profile of heat changes in the ocean underneath the atmosphere. And of course, with El Nino, you get an enhanced jet stream, you get these westerly wind bursts, you get and then that helps fuel storm development, mainly in the winter months, but also in the summer months after El Nino down in the southern hemisphere. So let's go take a look at what's going on at the ocean surface. That's really what matters. The subsurface profile we just looked at is good. It sort of gives you a hint of what's going on under the covers, but it's what's at the surface that ultimately affects what's going to drive the atmosphere above it. So we were seeing lots of warm water over here along South America, as we said, because there were multiple Kelvin wave in flight. Or 2 Kelvin waves, and weak at that were in flight, but just the same, it created warm water, and trades died over here as well. Now we're seeing upwelling cooler temperatures, and certainly nothing that looks like El Nino, but all the warm water that was over here has started to migrate to the west. And the El Nino monitoring zone, okay, like the Kelvin wave generation area we talked about before, is 120 west, 5 degrees north and south of the equator, over to 170 west. So we have warmer temperatures now. This warm water previously was over here. It is finally tracked into what they call the Nino 3.4 region. Nino 1 and 2 are right here. 3's like here, and 4's like over here, and they do a hybrid of 3 and 4 and say, if you have warm water in here, half a degree above normal for 3 months, for 3 consecutive 3-month periods, half a degree above normal, then you have some sort of El Nino. This is just barely in that territory. So kind of promising, but seeing cooler water developing here. Again, the trades are blowing from the east, so this cool water at some point is going to end up over here and sort of squash whatever's happening. Not so good. Here's the trend for the past 7 days. Blues suggest a cooling trend, not unexpected based on what we saw in the previous chart. Cooling around the Galapagos, little hints of warming starting to set up here along Peru. Nothing that we jump up and down for joy, but maybe something's going to start happening here, just sort of return to normal. And of course, there is your trend warming in this region, Nino 3.4 between 120 and 170 right in there. So some warming going on. Nothing remarkable though. Here's the backed off view, actual water temperatures. In fact, let's center it here. The one thing that jumps out of all this is look at all the warmth. I mean, it's not just in the Pacific. It's not just on the equator. It's in the Atlantic. If I was into hurricane monitoring, which I kind of am personally, looking at these warmer than normal temperatures here, knowing that we're in the year after La Nina, that would generally be favorable for hurricane production. And NOAA and some of the other long-term forecasters are also suggesting above average activity in the Atlantic this year. Anyway, but for our purposes, La Nina, there's a little cool pockets, nothing too bad, and general warming here in the Nino 3.4 region. Also notice this sort of warming band going on here. We'll just see what happens, but just a lot of warm water over the planet in general, but not really concentrated where we'd expect to see it over here, suggesting any imminent El Nino activity. So we've talked subsurface water temperatures. We've talked surface water temperatures. Now let's take a look at some long-term indicators. What's going on in the atmosphere? How coupled is the atmosphere with the ocean? Okay, Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. Negative numbers over a long enough period of time suggest the active phase of the MJO. Positive numbers, the inactive phase. Current value, pretty positive, 26.91, and just running on that for about 4 days. Notice we had I can't even say, it's just been, there was your negative run up here in early May. We knew that was the active phase of the MJO. So we've pretty much been lingering for a while now in some sort of inactive phase of the MJO pattern. In fact, here's the 30-day running average. It takes some of the noise out of this and suggests a trend that was down at minus 12, suggesting the active phase of the MJO, now moving to almost neutral, minus 0.44. The 90-day running average, we use that to look for El Nino, La Nina. Long-running negative numbers suggest El Nino. We're minus 0.71, so dead neutral. Neither El Nino nor La Nina, just kind of neutral. And then the ESPI index. So instead of looking at the difference in pressure between area north of Darwin and north of Tahiti, we're looking at absolute precipitation. Okay, less precipitation in here gets you a negative index, suggests La Nina. More precipitation here gets you a positive index number, suggesting more precipitation and El Nino. Current value, minus 0.55. So just slightly below negative, meaning still a little bit dry in here. Probably more the inactive phase of the MJO. There's no indication that that La Nina is in play anymore. Oh yes, the 30-day SOI moving average showed that, of course, back in 2015 into early 2016, negative numbers, El Nino. Then our little baby La Nina in 2016, and then here we are right now, May of 2017, just barely negative, but the trend is suggesting downward. You can draw a line through that, just like the trend here was downward and then going flat and then rising, now down, suggesting a retreat from La Nina, probably into just neutral territory. And two other bits of data, the Nino 1.2 index, just temperatures off of Peru, averaging minus half a degree. Notice it was warm here, kind of dropped off the past week or so, and minus half a degree. That's kind of maybe borderline La Nina if it continued for the next couple of months, which it hasn't and probably won't. And then the index that really matters, the Nino 3.4 index, again, that region from 120 west to 170 west, the official El Nino monitoring region. As of right now, temperatures plus almost 0.6 of a degree above normal, and you can sort of see the trend. It's been hovering at about 0.4 of a degree, and now working its way up a little bit. Not enough to be called El Nino, but trying to get warmer. We'll see what really happens. So right now, kind of undecided territory. Basically, we're in ENSO neutral territory, neither La Nina nor El Nino. Ocean and the atmosphere trying to make up their mind. They're coupled, but we're in the kind of a dead zone in general. In terms of the MJO, inactive MJO, trying to work towards the active phase, but again, not a lot of push in the atmosphere to go one way or the other. Sort of in a homeostasis sort of pattern. We've gone through a strong El Nino. We went a couple of years ago. We went into La Nina this year, and now you look at the heat dynamic in the ocean. Pretty evenly distributed, not a lot of push to go one way or the other. That tends to make for a rather, not an outrageous storm pattern. Just kind of, you get storms and things happen, but nothing huge, suggesting that the surf probably will not be anything exceptional as we go through the summer or even into the winter. Hard to tell whether we're going to go into El Nino, back to La Nina, or just sort of muddle along somewhere in the middle. My guess is probably somewhere in the middle, and maybe a hair dry for California the coming winter, but who knows? Way too early to guess or know. The models are undecided. So that's it for this week. We'll do it again next week on Sunday, regular time. Thanks for watching. Enjoy.